So this thing, it's a laser cutter, and I've been banging on about it for a little while now, saying that, well, it's just a tool. Anything you make on this, you could make with traditional tools. All this does really is speed up your workflow. It's more compact and a little cleaner, and so the space you need to work in isn't as great. But it's just a tool, and anything you can create on this, you could create with traditional tools. And we used it to make this thing, the crystal generator. And then I got a message saying, that's a load of BS. There's no way you could make that with traditional tools. I've worked with acrylic and it would be impossible. Well, that is a gauntlet at my feet straight away. And then another friend wrote to me saying, yeah, Rob, these are a bit expensive. Could you show us how you would make that using traditional tools? Because you've been saying it can be done. Well, would you mind us showing us that it can be done? And I thought, actually, there are two things. One, these are a bit expensive, and two, that is a really fair point. Money where your mouth is time. So, what I'm going to do is recreate this, but using traditional tools. Now, if you look at a machine, it's complicated when you look at it as one whole machine. But it doesn't matter how complicated a machine is, it will break down into components, and those components will break down into parts. So with something like the Antikythera, which looks very complicated, actually, if you watch the build video, you'll see that process. You'll see it being broken down into subcomponents, and those being broken down into parts. And you do the same thing with every single machine. So, with this thing, when we look at it, there are only actually 5 components. There's the magnet rings, there's the coil holder, there's the frame itself, there's the gear set, and then there's the handle. When we break it down like that, then we can see how much more simple the components are. Let's take this for example. This is actually just made up of 2 layers. It's made up of a layer of 5mm acrylic and 2mm acrylic. There are 2 reasons for that. 1, acrylic comes in 5mm and 2mm, and 2, the magnets are 5mm. So for these 2 magnet holders, we basically need 4 rings. And to make magnet holders, we need to make those discs. Now we've got available to us some acrylic. We've got some 5mm acrylic, we've got some 10mm acrylic, and we've got some 2mm acrylic. Now I can't think of a better way of cutting discs than to use a hole saw. This is a 150mm hole saw, and it goes in my pillar drill, and we'll use that to cut the discs. Now acrylic will melt, so don't jam the saw in there so you get lots of heat in there. Otherwise you'll just melt the acrylic and make a real mess. You need to let the saw cut, so you do it gently. So now we've got 4, we need to true them up and clean them up. That is, we need to make them the same size, clean at the edges, and so that the distance of the centre hole to the edge is equal. And the way we do that is stick a bolt through them to line them all up. Now you'll have 4. You'll have 2 at 5mm and 2 at 2mm. Stick the 2mm in between the 5mm because they're quite flexible. And as you're doing that truing up, they will bend and break. So if you stick them between the 2 5s, then they won't break. Now you've got 2 options on how to do this. Either you can stick in your pillar drill and hold a bit of sandpaper against it, or if you happen to have a hobby lathe, stick it in the lathe. And there we go, some beautiful discs to work with. Okay, so I've taken a compass and a protractor and I've marked off 30 degrees to create me 12 points so the magnets are going to go. That's the outside of the disc I've just made, and then 12.5mm in, I've drawn that line using the compass, because if I put a magnet in there, it'll be 5mm away from the centre. So now I can drop this on, line it up with all my marks, take a Sharpie, and where those 2 lines cross, just put a dot. Okay, so I've taken my disc and I've taken a 3mm bit and I've just drilled a little bit into where I made those Sharpie marks. It's a bit like centre punching it. And all we do then is take a 16mm spade bit. Remember, the magnets are 15, so I've gone a millimetre up just to give me a bit of leeway. Pop that on and then drill into that centre mark that you just made. Now the trick with acrylic is just not to go quickly. Remember, it melts. If you get heat from the tool in there, you'll gum everything up. So just take your time with it and it'll do a beautiful clean cut. Like that, and when you've done all 12 of them, that's what you get. Now we can put our backing plate on, use our bolt in the centre trick to line them up, bolt it down, and then put some of this glue in here so that the two pieces stick together, and we do that with both of them. And when that's dry, just spot a super glue in each one of these and then stick your magnets in, north, south, north, south. And there we go. 2 magnet carriers, handmade. The main difference being, that took me probably a good 2 hours and that took me a good 20 minutes, but that's how you go about it. Right, next thing. So we're going to make the coil holder, and to do that, well, basically we repeat that trick, but this time with 10mm acrylic and different size hole saws. And you basically want 12 small ones and 1 big one. So I got this hole saw set. I'm going to choose that one and possibly that one. So, we've got to make 2 discs out of 2mm acrylic, 200mm across, or 100mm radius, 200mm diameter. To do that, I've got this thing, which is a beast of a hole saw and needs particular care in handling, but it was also, I think it was about £125 just for that cutter. Now, you don't need to have a cutter like this. You can buy adjustable hole cutters that will cut pretty much anything that you want, or you can make your own. You can drill out the centre of a piece of acrylic, take a stick, drill a hole in one end where you're going to screw it through the centre that you've just drilled in your acrylic, and then 100mm away, which is the radius, you drill another hole and stick a sharpened nail through it. Then you just go round and round and round. The sharpened nail will cut the acrylic. On 2mm, actually, it's no problem. It'll do it pretty easy. On the more chunky stuff, then it's gonna be a bit more of a challenge, but you'll do it. And that's what I mean. Not having the right tool, or not having a tool that will do that job, doesn't mean that the job can't be done. It means there's a workaround that you need to find. And there's always a workaround. I mean, it'll be a chore, for sure. But that's why we have tools, to make it less of a chore. But it doesn't mean you have to have them. Now this thing, if you do happen to have this or another hole cutter that you put in your drill, don't go at it like a bull in a china shop. The secret of acrylic is care. Take it slowly, it'll cut it beautifully. So let's cut our hole. So there's our collection of discs we just made. There's the 2 massive ones, there's 12 little ones, and then this medium one that we made. Now we're also going to need this, which is our template from earlier. What you do is take one of the massive discs, line it up with the centre, take this one, line it up with the centre, and these ones get lined up with the cross points that we marked for the magnets. And this is why I wasn't too particular about the size of these. As long as there's a gap there that our wire can go through, it doesn't come out to the edge and there's room there, that's all that really matters. And now we glue all those ones in place. And that's it all glued together. And I've already drilled this out with a 22mm spade bit and stuffed a couple of bearings in there, same here, so the top fits on there. And now we're ready to put the coil in. And I'm going to use a serpentine coil as per, and I've done an awful lot of videos and tutorials on how to wind these coils, so I'm not going to bother doing that again. And they just stuff in between there in the gaps between these circles, going all the way around. When you've done that, put the top back on. Okay, and that's our coil section finished. Obviously the magnets then go on there like that, and the magnets will be made to spin. The coil section's made to stay still. So to make gears, what we need to start with are discs, and these have been cut in exactly the same way as of all the others, but out of 10mm acrylic. What you would do now is either put them on an index head, use a gear cutter and cut the teeth out, or paste on a template and go at it with a fret saw. I want to introduce you to this stuff. This is power transmission belt, actually timing belt, and it comes in all kinds of sizes and all kinds of teeth, from this nice chunky one to this rather delicate one that you use in things like 3D printers. And really, it changes the rule book in making gears. All you do is wrap it round, chop it off, glue it down with super glue, and super glue is made to stick this stuff, and hey presto, instant gear. I thought that was just ridiculously easy. Okay, we've used acrylic, but you could use any material and create yourself a gear really, really easily, and in many sizes, because this belt comes in many sizes and you get it from Amazon or eBay. It's really easy to get hold of. Anyway, moving on. Now we have to create a handle, and this is a bit of 10mm acrylic, and to create the handle I've drawn this circle which is just bigger than the instant gear so that the cogs are hidden by it. Then we've got another circle here, it's about 30mm in diameter, that's going to take the handle itself, and I've joined them up with this pretty little line so that we get a nice smooth curve between the two. And of course what we've got to do is cut that out, and that's not as easy as cutting out a circle. First of all, we drill out our two centres so that we basically don't lose our marks at 8mm. As you're trying to drill through, you find that the acrylic does melt like this and collect in these swaths. Stop every now and then and just clean everything away. Sometimes you'll get gumming on the end of your drill bit. Again, stop and clean the gumming. If you let it build up, it'll actually make the hole much bigger than 8mm. So just stop every now and then, clean your drill bits. When we set everything up, well, then we cut it. Okay, I've removed most of the waste with the mechanical saw, and now I need to remove this stuff, and I do that with this thing. It's clearly a belt sander held in my vise, and all I do is turn it on and take the extra waste off. It's an 80 grit paper, so it'll rip that waste away. And when you've done that, that's what you'll get with the handle sticking out. Now you do get a bit of an awful edge on it, and it's time to clean that up. By the way, don't run this too long because you're blocking the air vents and it does get hot, so don't let it overheat. So you can sand that if you want, but what I tend to use are these things. They're box knife or trimming knife blades, and I use them like a cabinet scraper. So you take it in your hand and you just run it around the edge. It's a bit squeaky and horrible, but it will carve off in very thin layers the acrylic, taking all this horrible gunk off and leaving you with a nice finish. It takes a while. Now when we've done that, we can take one of our instant gears, join it up there by sticking a bolt through it, and then glue the instant gear to the handle. Okay, that's done. Now we do need an actual handle, that bit there. And for that, I've got this. It's an old roller. We're going to remove the metal, drill it out to 8mm, use a bit of acrylic rod so that it sits there, and then make a cap to go on there to stop the thing sliding off. So for the handle, I've got two discs cut in the normal way from 10mm acrylic. One's small enough just to go inside the handle, and one's large enough that it won't. And I've got 17cm of 8mm acrylic rod. That glues in there. Handle's been drilled out, so it glues in there. These two glue together, and then when you swap them on the top, it will drop in like a peg. Push it down, not so it catches the handle, and then glue it in place. Like that, so it's free to turn. Okay, so we've got our handle, we've got our instant gears, we have our magnet carriers, we have our coil. So all the parts are complete apart from one thing, and that's the frame, and that's the thing that holds it all in registration. So for the framework, we're going to need 4 parts. We need a base plate and 3 uprights, and they're going to be made from 10mm acrylic. And I always use the same routine, and that is saw, shape, sand, scrape. So let's saw our base plate out. Then I use my upside down sanding trick. And then finally go at it with a scraper blade. Now I use these things, if you're a bit worried then buy a cabinet scraper, but just scrape the edge clean. And there you go, one base plate with rounded corners, and the blanks for the 3 uprights are going to be made in exactly the same way. Saw, shape, sand, scrape. So before cutting the uprights, I took myself a bit of 1mm acrylic and do this shape on it. And all I did was lay the gears on the top. I drew a centre line, popped the gears on to make sure that the centres were apart, and dotted the centres. And then I drilled them out with a 3mm drill bit. Well, actually just kind of indented it so I don't lose those marks as I work on this piece. And remember that it's a bit like a centre punch. Now what I've got to do really is just cut them out. Now there's an additional 2 dots there and there, and they're going to be drilled out with sacrificial holes. So I'm going to drill them out at 8mm, put a bolt through the 2 bits and shape these 2 bits at the same time. And that means they'll be the same shape. Now from a construction point of view, it doesn't really matter if they're the same shape or not. What matters is that these 3 holes where the bearings are going to go are in line with each other. And as long as you kept that bottom edge flush and drilled straight the way through, they will be in line each other when we glue these to the base plate. Okay, let's glue some bits. You need to make sure this first bit is square and straight. So measure it from the edge before you glue it and check that it's square. I've got a little tool to check that it's square, but anything will do. So this bit of acrylic, for instance, got a nice square edge right there. But check that it's square and get it glued down. So to finish this, we're going to need a couple of extra bits. One bit is a bit of 8mm, 300mm long acrylic rod. You could use steel if you want, and that will form the axles. You need 3 axles, one at 120 and 2 at 60. Now they're kind of rough because you're going to make it slightly differently. When you put the axles in, they'll poke out a bit, so saw them off. The next thing we're going to need is a whole bunch of these. They're 8mm washers, because we're going to use these to pack the gears out to make sure that all of the gears line up, and the first gears to fit are one of the large cogs and one of the small cogs that go through the centre lower bearing. So it's like that. Now the other small gear goes on this side through that hole, and it takes the long axle with the long bit sticking out this way. Like that. Then finally this handle goes on here with the other one that's about 45, 50, and it fits on that last one there with a bit still sticking out. So it's like that. Then of course we turn the handle, the big cog turns the small cog, it's attached to this cog. Turns out that's attached to the axle, and that is what drives the magnets. When we've got it this far, of course we can slide our second plate on. Okay, that's the gearing done, and I've added this magnet carrier on the axle, so all we need to do now is take our coil. It's got bearings in there, that feeds onto the axle like that, and we need an upright there to hold the coil still, and then we can feed on our last magnet carrier. So the upright to hold the coil is just a square of acrylic shaped for the ring, but I always cut things like that from the edge. If I cut it from the edge, so if I cut it like that from here, then that edge there is nice and square. Now when I was at school doing metal work, we used to glue this and use an engineer's square and file it, and it took forever. Using that edge is a simple trick to get a nice square edge very quickly without you having to do all of that. So cut from the edges when it's things that you need to be 90 degrees. And that's it, finished. Now we could cut that off if we like, make it nice and neat, but now the second magnet ring is on, then this north magnet here faces directly that south magnet there, so we get the magnetic field at 90 degrees to the wires. The magnetic field is going straight through that way. As I say, we'll do it automatically, they're close enough. If you haven't got them close enough, you'll have to twist them to arrange them so that it is north facing south, and then put a spot of glue in there to hold the whole thing. Okay. That's it done. Let's see if we can get something out of it. So I've got my little setup here. It's nothing special. It's just a light bulb. We're going to turn this and see if we can light it. And what that will mean is it's over 20 volts because the turn on voltage for this thing is 20 volts. Okay, let's give it a go. That's awesome. Talk about... Oh, hey, how bright. Yeah, that's... really cool. So in this we used instant gears. Some may say that's cheating. Nah, I mean, I could have sat there with a fret saw and cut them out like thousands of woodworkers before me, but I thought that would be a nice way of showing you that those instant gears actually work really quite well, and I hope it's a help for people to make gears quite quickly. If you want to make gears in acrylic, you do it the same way as you do in wood. Paste on the template, go at it with the fret saw, and be patient. So the point of this video? This is a tool. We use it to make this. Then we use traditional tools to make this, just to show that anything that's cut on a laser cutter you can make with traditional tools. And of course, we already know that, because we made this, remember, on the laser cutter. And this was made by traditional tools thousands of years before laser cutters were even invented. The only difference, really, between traditional tools and the laser cutter is, in some instances, they speed up your workflow. They speed it up incredibly. This took, I think, 3 or 4 days to build. This laser cut one took 3 or 4 hours to build. The amount of mess this created took me another half a day to clean up. And of course, there was an awful lot of waste. The amount of mess on this took me, I don't know, 5 minutes to clean up. So there are differences, yes, but it is only a tool. And we now know that we can reproduce anything on a laser cutter with traditional tools relatively easily. All you really need is a bit more patience in doing what you're doing, but when you see a laser cutter video, don't say to yourself, oh, that's not for me. Have a look at it if it's an object you're interested in. Break it down into its components. Have a look at the parts. Ask yourself, how can I make these out of another material? And then go right ahead and use it as the springboard for your idea. If you say to yourself, oh, laser cutter not for me, then essentially you're sticking your head in a box. You're narrowing your vision down. And to me, well, that's not a good idea. But it's your head, your box, knock yourselves out. Anyway, I hope you enjoyed the video. I hope it was helpful, and some of the things that I talked about that I do when I'm making this stuff, I hope helps other people. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.